This is a video for 823 on negative exponents. In this lesson, you learn how to work with negative exponents. So it says 2 of the problems below are correct and 4 contain errors. Expand each original expression to verify that it's correct. If it's not, identify the mistake and simplify. So this first one, I would do x to the third times x to the fourth, which is x to the seventh, and y squared. So this one is correct. For b, I would do 2 to the third times 2 to the fourth, which is 2 to the seventh. So this one's incorrect. They multiplied instead of that. The correct answer is 2 to the seventh. For c, I would, if I wrote it out, it would be 7 times 7 times 8 times 8 times 8. 7 times 7 times 7 times 8 times 8. Get left with 8 on the top and 7 on the bottom, so it's 8 sevenths, so this is correct. So this one they multiplied the bases, so it's incorrect. The correct answer is 3 to the 7th power, so you do not multiply the bases. For this one, they did 2 minus 5 is positive 3. It's actually 6 to the negative 3, which is incorrect. Or if we had written it out, we could have said it's 1 over 6 to the 3rd power. That's possible. This one, you get 0, so it's z to the 0 power, which actually equals 1. Anything raised to the 0 power is 1, so it was incorrect. So negative exponent rule, so 5 to the negative second is 1 over 5 to the second, which is 1 over 25. Negative 8 times 5 is negative 3 to the negative third, so it's 1 over 2 to the third, which is 1 over 8. So the rule is a to the negatives, you find the reciprocal, okay, so it's like it's over 1, so you flip it over, and it becomes 1 over 8 to the negative, or positive. Okay, so 3 to the negative squared is 1 over 3 squared. 2/5 to the negative 6, reciprocal, 5 over 2, the positive 6. So you flip the fraction over and make the exponent positive. So it says create fractions from these expressions and show how you use a giant one. So you using the rule, this would be 6 to the 5th over 1 times 1 over 6 to the 3rd power. So when I combine them, I get 6 to the 5th over 6 to the 3rd, which equals 6 squared. This one, w to the 5th, 1 times 1 over w to the 2nd, w to the 5th, w to the 2nd, I get w to the 3rd power. This one is 1 over 10 to the positive 4th times 10 to the 5th over 1, so 10 to the 5th over 10 to the 4th, or just that. So now it's time to reverse your thinking. If a negative exponent can create fractions, then fractions be written as expressions with negative exponents. So simplify the expressions below to write your answer in 2 different forms, as a fraction and as an expression with a negative exponent. So 3 minus 2 is negative 2, so I have 6 to the negative 2nd power. Rewrite that as a fraction, I get 1 over 6 squared, or I could say 1 over 36. For b, 5 minus 6 is 1, so it's m to the negative 1st power, or 1 over m, or m to the 1st power. 2 minus 5 is negative 3, so you get 10 to the negative 3rd, or 1 over 10 to the 3rd, or 1 over 5. So it says rewrite each expression in simplest form. So basically to make the exponents positive, I have to flip over my fraction. So I just rewrite it as y to the 5th over x to the 3rd. For this one, the n goes down because it flips over. So I get 1 over n to the 7th, n to the 3rd. The b goes down into the denominator because it flips over. So I have a to the 2nd over, actually, Let's use the quotient rule first. 2 minus 7 is negative 5, so I get a to the negative 6. And negative 3 minus 6 is negative 9, so I get b to the negative 9. So they're both over 1. So then I flip them. I get 1 over a to the 5th, b to the 9th. Okay, I'm going to do the same thing with this. I'm going to use the quotient rule first. 2 minus negative 1 is 3, so I get r to the 3rd. Negative 3 minus negative 5 is 2, so I get r s to the 2nd. And then t to the 0, 0 minus 3 is negative 3, so I get t to the negative 3rd. So the positives stay in the numerator, but the negative goes to the denominator, so I get r to the 3rd power t, r to the 3rd power s to the 2nd over t to the 3rd. Okay, these ones are kind of combining habits. So b to the 2nd to the 4th, because I do the exponent first, I have b to the 8th, so b to the 3rd times b to the 8th, or b to the 11th. So I'm going to do the power to the power first, w to the 8th power times 6b to the negative 3rd power, w to the 5th, 3b to the w. So then I'm going to combine the w, so I get 6 w to the 12th, b to the negative 3rd, over 3, I'll put w first, w, b, alright. Use my quotient rule, 6 divided by 3 is 2, so 2, 12 minus 1 is 11, and b to the negative 4th. And then I rewrite it, 2w to the 11th, or b to the positive. For this one, I'm going to multiply first. X to the 4th power times x to the 2nd is x to the 6th. Negative 7 plus 3 is y to the negative 4th. Reverse the y, so I get x to the 6th over y to the 4th. This is what I'll do the most inside one first. So r to the 3rd, s to the negative 2, r to the 20th, s to the 12th, with second power. So combine inside, r to the 23rd, s to the 10th, raised to the second power. So I get r to the 46th and s to the 20th.